Thank you for coming. Okay, this is it's a little more sort of improvised because I focused so much on yesterday, but I think I have some different stuff. So one thing that I wanted to point out, actually I was talking with, I spent a lot of the last month kind of chatting with Oliver, who was really helpful in helping me sort of sort through all this and deep dive in. And one of the things that he pointed out that I thought was interesting to share is InfoQ over the years does these, I guess, surveys or studies about trends. And you can see here that, sort of like innovators, early adopters, early majority, and late majority. And this one is from 2022. And you can see that in the column for late majority, so microservices is already in the late majority, right? It's pretty mature. And the one before that is modular monolith. So clearly modular monolith is coming in chronologically afterwards. But under modular monolith, you also see correctly built distributed systems, right? So it really is an indication that we learned microservices was, it was a phenomenal trend, and we learned a lot, but we didn't always do it right? And because you can write a microservice architecture that really is sort of a distributed monolith as well, right? If you don't define your bounded context and things correctly. So we learned also better about how to do domain-driven design and correctly build our systems, and that is sort of maturing more at the same pace as modular monoliths. So sometimes coming in second or a little bit later lets you take advantage of the lessons learned of the previous trend. So that was interesting. And then this is from the keynote yesterday, but I just kind of wanted to come back to this idea that Spring Boot brings us all of this technical foundation, and even you can see in the annotations, right? At repository, at entity, at all these things, right? They're really oriented on technical layers, and all of the integrations are generally oriented around including technical stacks. And so Spring Modulith is really taking a different approach. And I'll mention it a little bit later, but also there's sort of like a tangential project, I would say, called X molecules in general, J molecules specifically, also from Oliver, bringing in annotations that are more aligned with domain-driven design. So you can also have the semantics in annotations that are more domain-driven rather than technical. So these two projects they're both foundational, and they can both basically, you could argue that they could be applied to every application maybe. Regardless, you could have a single module microservice, right? But they're really addressing kind of different layers, technical versus architectural. And then, when you want to have multiple monoliths, then you can talk about how you address those distribution needs. What else did I have? Okay, so then I also came up with this table to kind of try to compare microservices with other options. And so this is, I think over the last 10 years, I think we've all had so many conversations about microservices and their benefits, but one of them is team agility and this idea of Conway's law, and how you organize your teams is going to impact how your software is built. And so if you can organize your teams around more cross-functional teams, and also allow teams to work on entire things of a single concern and deploy independently. So you have this sort of team agility built into microservices. Of course, if one microservice fails, it's one process, so you can incorporate strategies to deal with that fault tolerance, and you don't have a process level failure that brings down everything else, every other module, for example. You can scale things individually. That physical separation of space helps you enforce bounded context, assuming, of course, that you did the design correctly. Then and you're not ending up with a distributed monolith because you have too many inter microservice relationships. But assuming you did your design correctly, then that physical separation is going to help you enforce those bounded contexts. Of course, protected implementations, because microservices only expose what they expose through the API. You can test them independently because they're separate Spring Boot apps. the distributed tracing, the one we're used to over the last 10 years that looks at network hops. All of that is available with microservices, and so those are some of the reasons we moved to microservices. But there are the drawbacks, right, that we all know. It's hard to manage once you have a lot of Git repositories, and then it can become kind of messy. Distributed systems are not easy, and then often you need more infrastructure, right? So, and then the ease of refactoring boundaries, it's not actually that easy with a microservice architecture if you decide that your boundaries are different, right? You often have to refactor APIs, API version management, combine repositories. It's not that simple, even though we've enforced good boundaries. To then revisit that is not necessarily that simple. And then with traditional monoliths, you kind of almost have the opposite situation, where all of the X's that you see here, except for the middle one that's X sum both, are kind of the reasons, right? The motivations that we have to go from monoliths to microservices. And the benefits are really just like, if all your code is in one place, of course, it's in that sense, it's a little bit, it's easier to access, it's all there, that's kind of convenient, and you don't have to deal with all of the distribution. So this is, the Modulith can kind of give us that middle ground. And I would say that it incorporates a lot. It's often referred to as the best of both worlds for good reason, right? We have from all of the everything that's green in microservices is essentially green in the modular monolith, except for process level fault tolerance, because if your process goes down, everything goes down. It doesn't mean that you can't make your Modulith more fault tolerant, right? You can still incorporate the same strategies of if something goes wrong that's not a process failure, then you can still maybe have some kind of circuit breaker functionality, or some kind of some fallback actions, or something like if you can't access a back-end system, you can still have fault tolerance. But of course, if the process goes down, the whole thing goes down. And the selective scalability. Again, it doesn't mean that your Modulith isn't scalable. You can introduce caching, you can introduce other techniques, but as far as just scaling one instance of one module, of course you can't do that, right? So, and then the other interesting one is the ease of refactoring boundaries. It is a little bit easier when things are within a single code base, and you're just sort of like moving code around and maybe defining some different boundaries, but it makes it a little bit more flexible. And I think in that sense also, it's a really big leap forward in terms of refactoring monoliths. I think there's a lot of monoliths that we haven't refactored, and hopefully with modular monoliths, that's going to open up our possibilities there. I was just looking through the issues on Spring Modulith, and I ran across this comment, which I really love. This was, within a conversation that had to do about some specific issue. But I don't know Marco Reitano. I don't know if he's here by any chance. But he wrote, thanks to Oliver. He wrote, "Thanks for your work with Spring Modulith. I'm exploring it in my master thesis, and it prompted me to reread the Domain-Driven Design Red Book. Working with Spring Modulith in combination with JMolecules, which is the library I mentioned that brings the annotations that are the semantics are more in line with domain-driven design than technical. It greatly improved my understanding of consistency boundaries, aggregate and module design, domain events, etc., something I was always unsure of, even in a microservice context, resulting in dependency hell, distributed big ball of mud in the past." And I find this really interesting because even though microservices did sort of cause this revived and concentrated interest in domain-driven design, and I think it made domain-driven design more approachable. This is evidence that domain-driven design is still hard, right? And it's still a little bit sometimes elusive. Sometimes I think we understand it in theory, right? But it's hard to translate that into something concrete. And so even though microservices helped us advance our understanding and our practice of domain-driven design, I feel like modular monoliths is going to make it even that much easier and that much clearer for us. And I feel like this quote was really nice evidence of that. So then these are just like, I think, a few other things I wanted to mention, but let me see what else I have here before we, so I just threw some links in here. Let's see. So this is a link to that JMolecules library I mentioned. Just, you can go look at it. This isn't, yesterday when I was talking about the timeline, the origin story of Spring Modulith, I mentioned Spring Boot and ArcUnit, because those two projects are really fundamental to Spring Modulith. JMolecules is a project that is more tangential. Like it's not required. You don't have to have JMolecules in order for Spring Modulith to work. But if you have JMolecules, then the annotations in your code, you can use the annotations from JMolecules as opposed to more technical annotations. It'll eventually resolve to the annotations that you need to create entities and unique identifiers and one-to-many relationships and things like that. But the annotations themselves that you're using will be more things like aggregate root and things like that are more sort of semantically within the domain-driven design vocabulary. So that's something that you might be interested in. What else do we have here? And then some things, I'm going to show you some code, but some of the things that I didn't include in the demo, so just so you know that they exist. This is the documentation for Spring Modulith, and it also has a passage of time API where you can include things like, at every quarter or at every month or every, sort of like a cron job in your Modulith if you need to trigger something to happen at a certain schedule. So there is this moments of passage API. And the last one that I included here, also from the docs, is just that there's an additional actuator endpoint that has some Modulith specific. So if you're exposing your endpoints, you might want to also expose the health, info, whatever. There's also a Modulith endpoint that has some information. So that's also good to know. So I think just because this is, I know you were all here for the keynote, but since this is recorded and it should be a self-standing talk, I'm just going to quickly sort of go over the technical aspects that are included. So I found this a useful way to categorize what Spring Modulith does, to say that it, for verification, both for your architecture and your code, it helps you with visualization of your design and at runtime, and it helps with integration of modules with each other within one Spring Boot application process and also with external systems. So just to quickly recap that, when we talk about verification, we're talking about taking your logical architecture and helping you put that into some kind of concrete terms. And in this case, what we're talking about is an opinionated code arrangement. So this is where Spring Modulith comes in and says, it is your package, your package structure that is going to determine what your modules are. And it differentiates between top-level packages and sub-packages. And so I think one interesting thing to point out here is if you notice in the example.inventory, we have two classes, inventory management and something inventory internal. The plus sign next to inventory management means that that class is actually declared as public. So even according to the Java compiler, that class is visible to other packages in the same Spring Boot application. And that is acceptable according to Spring Modulith's architectural rules. Public top-level package is considered API. Something inventory internal.java, the minus sign means that this class is not declared as public. So the Java compiler already limits visibility of this class just to the inventory package. Spring Modulith cannot make the Java compiler less strict, right? It's not going to take away from the Java compiler. So you don't have to put something in a sub-package in order to make it internal to the module. You can have it at the top level and it's simply not public. However, if we look at the internal package, example.order.internal, that class, something order internal.java, is also public. You can see from the plus sign, right? It's declared as public. The reason it's declared as public is because it has to be, because we want to access it from order management within the same, like its parent, right, in the same package. And so what this is really showing is that the Java compiler itself is not sufficient to help us provide this kind of visibility control that Spring Modulith is trying to do, right? As soon as you take a class and you put it in a sub-package, you have to make it public, and as a result, you make it visible not only to its parent in its own line, like ascendancy line of packages, but to everything in the whole application. So the Java compiler is kind of falling short, and that's one of the reasons for which we haven't been able to impose the right visibility control in single applications so far. So that's why it's important what Spring Modulith is doing. So it doesn't matter that something order internal is public from the perspective of other modules, right? Spring Modulith is going to allow the Java compiler to continue to make that visible up the line into the order module, but that's it. And then it's not going to be visible from inventory or any other package, or even application.java, right? The example package is also, it's like inferred as a module in a way, right? It's also its own package. So even from the application.java, you cannot access something order internal, even though something order internal is public. So that's how it's kind of working with the Java compiler. It can't make the Java compiler more lenient, but if the Java compiler makes something public, it can make it more strict, right? You can add to it. So this is where, and it enforces these, right? I mean, it has opinions, but these opinions are enforced, and they are enforced through tests, right? So you don't have to change your code, you just have to arrange your code in the right way. So that's cool. Testing modules independently. We also mentioned this yesterday. You can, there's 3 different Bootstrap modes. The default Bootstrap mode is standalone, so you would only load the context for the one module that you have declared that you put this annotation on, application module test. But if you try to load that one module, if you haven't, mocked things out and eliminated dependencies for testing, then you actually might need to load dependencies. So there's 2 other modes. There's direct dependencies, which is kind of like your children dependencies, things that you need, and then there's all dependencies, which is like the whole line, everything in line above you and below you. And so yeah, I think all dependencies is good. So then. Okay, so that's how you, for verifying your code, right? Making sure you're following architectural rules and then testing one thing at a time. Visualizing, here we made the difference about visualizing your design versus visualizing your runtime. Visualizing design has to do with producing documentation, and there's 2 kinds of documentation. There's defaults where so you can just kind of call a method, and you can create in your test class, you create a document or object and you just call a method called write documentation. But also if you want to go in and customize things, there's a couple of different formats supported, and there's some options there. This is the default. I think this is the default. So you get a diagram and you get a table. But you can see that it's all kind of top level. It's just describing what's architecturally important, right? We don't really know how inventory is implemented or how order is implemented. We don't really care about those details because those details are internal. It's whatever the implementation is. But this is automatically generated, so that's really convenient. And then at runtime, this is where we have something like distributed tracing, right? Where distributed tracing normally only tells us about network hops. And here, Spring Modulith is going to automatically add a span ID for every every API entry point, right? So at every top-level package, anything that's public, so any way you can enter a module, that's going to be assigned span ID generation, and that way we can see. So in this particular single Spring Boot application, we have an order module, we have a payment module, we have an engine module. And interestingly here also, you can see that actually the payment completes in 21 milliseconds, but then we have the engine that takes half a second. So that kind of almost doesn't make sense, right? How can you say that payment completed in 21 milliseconds when there's a step in the request that took half a second? And this is because this one is an integration with an event. So payment published an event, and then the payment API finished, and then the event was picked up by the engine module, and the engine module has an intentional delay to kind of create this sort of visual situation here. But the Spring Modulith is still able to correlate based on that trace ID that all of these things have to do with the same request. So you see it all, you see the flow for the entire request, even though it's an asynchronous operation. And then as far as integration, again, you don't have to integrate things through events. Events is a great way to asynchronously decouple things, but it's not the only way that you can make modules work with each other. But if you do this, if you are working with events, then there's a particular situation where there's a recommended configuration for how those events should be handled. So again, we went over this yesterday, but if you have code like this, there's two problems with this code. One problem is that you're from a code perspective, you're coupling order and inventory. So if you wanted to add a third system, like an email notification system, for example, that also needs to respond to events, you need the code to be accessible to order, you need order to know about it, right? You need to change order in order to add email. Not great. And then also, if order is transactional, right? So order is going to have a commit boundary, and it can't close that commit boundary. It can't release its resources. Maybe it has a database connection open. It can't release any of that until inventory and rewards are finished, and who knows how long they would take. So it's better to do this through an event. So if you are working within a Spring Boot application, and these are just two top-level packages, you don't necessarily want to bring in this infrastructure with Kafka or Rabbit or JMS. Spring Framework has an in-memory messaging system called application events. So you can just issue an application event. But if you do that, the default configuration for these application events is that they're synchronous. So even though you've decoupled the code, the order still has to wait for all of the subscribers to finish processing the event before it can close its commit boundary. So it's better, but not perfect. So what we really want is to make the events be processed completely asynchronously, right? So we want to configure the events away from the default to be asynchronous, so that the order can finish its commit boundary. And then because we're handling events, we also want each subscriber, each listener, to then initiate its own commit boundary. So that combination of configuration, which is the recommended one, is all compacted into this one annotation provided by Spring Modulith. So just to make sure that you do it right, and just to make sure that it's easy, that's how that works. And again, as we mentioned yesterday, that's great, but there's still a risk of losing the message, right? Because everything is still in memory. We're dealing with an in-memory messaging system here, right? So if the application does fail, if the process crashes, or if the listener fails for some reason, we could lose that event. So we can write it to a database. It gets serialized. It has information about the listener. It has information about the published event type, and it has the actual serialized message. And anything that so as soon as the message is published, it gets automatically, if you opt into this database, when the message is published, it gets automatically written to this database. And when the listener processes it, it updates the database with a completion date. So anything that doesn't have a completion date means that it hasn't been obviously processed yet. So if anything crashes, this is published to, in this case, I'm using Postgres for this example, but any external database, so that when the listener starts up, you can also opt in for it to automatically reprocess events. And you have to opt into these things because you may not want to automatically. You might want to evaluate them or expire some of them, or who knows, based on whatever conditions make sense for your business. So that's leveraging Spring Framework's in-memory messaging. If we want to publish events to external subscribers, of course, if you want to share, right? If the Modulith has to interact with other systems by way of publishing data. Or the other interesting use case is like, okay, I have all these modules. Maybe I do want to take one out and make it a microservice because I want to scale it independently, or for whatever reason, maybe you're, whatever makes sense, geolocation, whatever makes sense to your business. How can you easily take that and move it away? So if you are integrating modules through events, then what you need to do is change the configuration. So instead of using application events in memory, you're using something like a Kafka or a Rabbit or something like that. And so again, Spring Modulith is giving us annotations that will make that really easy. So you can imagine, not available right now, but you could imagine either coding this yourself, or maybe one day, part of the project, like a very quick sort of one-line thing that will do this for you, right? Because it's a very simple, kind of predictable configuration change. So we could get to a point where it's really easy to just take something out or put it back in. And then this last thing that we mentioned yesterday. So this is new. So, I mean, even before this feature came out, you could tell Spring Modulith. If you had legacy code in an application and you had code that you had already refactored into modules, you could configure it to tell it to ignore the legacy code, but it was really ignoring it like it wasn't there. So it wasn't going to recognize it for documentation or distributed tracing or anything. So you also lose a lot of benefit, which is not ideal. So since Friday with 1.2, there's actually support for something called defining an application module as type open. So what this does is that for the whole package and all of the sub-packages, the whole tree, it says anything in here can be used by any other code in the application, still recognizing that it's a module. So you don't lose the benefits of that, but also you don't have access violations. So it puts you in a position where you can have a coexistence of code. If you and the nice thing about this application module type open is that it applies to like a whole package and all of its sub-packages. There is another option for exposing an individual class, right? Because we have this very opinionated code structure, which is it's a nice default, but sometimes you do have a class in an internal sub-package that maybe you do want to expose despite the default opinionation. And so there is an annotation called @NamedInterface that you can apply either to an individual class or you can apply it to all of the classes in an individual package. But this type open applies to a package on all of its sub-packages. And then the other thing that I would say those are your two options. So application module open for a package and sub-packages, or @NamedInterface to be a little bit more specific about what you're intentionally exposing. There's another way to override the defaults of that opinionation, which is to say, I'm a module, and there's 10 other modules in this application, but I want to make sure that from my module, I don't actually access all 10 others. I want to limit that access and say that I'm only allowed to access these 2 other modules, right? So kind of limit what I can access. And so you can also do that. You can go into the package and say explicitly that you can, again, in a package info.java file, sort of list the modules that you're allowing that package to access. So you can have a little bit more control on those boundaries. Okay, so how much time do we have? So I have some code. There's 3 branches in this repository here. This is like a RESTbooks application. So let's see if we can get through those. Let's see. Where are we? Yeah, and if you have any questions, you can just yell them out. So let's see. What are we doing here? Let me just... Okay, let's see if I remember this correctly. I think for the first demo, I don't need this, maybe? Hope for the best here. Okay, so we have an application. And it's just like a drink ordering. So you can see we have some modules here. And I think all I wanted to show here was we have some modularity tests. Is that big enough? No? Okay. 1 second. Settings, editor, font. Let's see, maybe 20. Double what? Oh, really? And then what? And Zoom. Wait. Start typing Zoom? Really? Oh my God. Wait, did that work? Okay, maybe I'll practice that later. Okay, cool. Okay, so here's our test to verify architecture. Super easy, right? Application modules, feed it the class, your main class. Is that big enough though? Yeah? Okay. So we're passing it our main class, and so basically what this is doing is it's building a model of our modules. And all you really have to do is use that object and call verify on it. I'm also doing a system out print line just so you see what is printed to the output. And then the create documentation is you create a new documenter, also pass it that model that we've loaded, and write documentation. Of course, as I mentioned, you can also have you can configure this differently, and there's some you can play with the defaults. And this is I just have an extra method here just to create a document where I can easily kind of like have an index file that references all of the different documents that are going to be generated by this. It's just a little convenience. But these are the two important ones. So where's my, wait, what's happening here? This is not interesting. And okay, so our system out print line printed out this. So you can see that it knows that each top level package is a module, and it tells us if they have any dependencies and if there's any Spring Beans in there. And then it tells us if they're public or private, right? With the plus, or the plus is public and the O is internal to the module. So we get a little bit of information just printed if we just do the system out print line. And you can see all of the tests passed, or the important one is the verification one. And then what that means is by default in our target directory, we have a directory called Spring Modulith docs, which is interesting. What's happening here? Okay, I don't know exactly what's happening. This is weird. Does anybody know why this is? Let's see. Let's do maybe reload from disk. Interesting. Is this why? Okay. All right. So normally you just get these files. You'll get a component, a UML diagram, and an ADOC for every module. So you have the core one, the drinks one, the engine one. You also get a components file for all modules. You need to have a plugin in your IDE to render this information. So this is the entire application. You can see here, listens to implies that we have an event there, uses, depends on, things like that. For every module, you'll have like a subset of this, and you'll have a table. So this is the convenience method that I had added this just to get them to all load as one. It should just take a second. So there we go. So okay, so this we have, so here's our entire application, and then for each individual module, we have a diagram that focuses on that module, as well as whatever information is available. So depending on how complex and how they interact, we have base packages. This one has controllers, it has repositories, we have our aggregate root. So anything that's sort of architecturally important is what we're given. But this is super convenient just to have this generated. So that's really great. There's one other way to override the defaults, which is under, I think it's here. So we've declared that this package actually, there's one package that everything shares. So what this means is that when we test an individual module, the core module will always be loaded with it. So even if I wanted to test something and I said standalone, and I didn't declare all dependencies, this core module will also be loaded with that. So you can also, override that. This impacts testing. So okay, so we have those two things. What else do I want to show you here? Maybe I think at this point, let's see. Let's quit this and let's see. Let's do, oh no, we don't have to do that. Okay. So let me start this. I'm going to start this with observability. So what this is going to do, so I want to show you Zipkin, and I also want to show you publishing events. Okay, so we've got our, let's see. Okay, so since we have POM file here, and we can go to our observability profile. Okay, so here we have, so we've added, importantly, we've added integration with Zipkin for distributed tracing. You can see all of the different actuators, all of the different starters have to do with tracing and micrometer. So this is what's going to help us generate those spans automatically at every entry point for every module. I've commented this one out because I just want to make the results in Zipkin a little bit clearer. In the sense that I only want to show you the spans that are generated for the modules and not the spans that are generated by Spring for the database interactions. If you were to comment this in, you would also get additional information in Zipkin that shows you every time a module goes to the database. But just for clarity, I've commented that out. I'm using the Docker Compose integration in this case to start up Postgres and Zipkin. And then the Postgres we're using for the event publication registry. So we have our database here. And so besides having our the database that the actual application is using, it creates this additional table that we're going to empty out. So let's do delete. Okay, so let's say our database is empty right now. Okay, so our app is running, and let's go ahead and submit some, I think there's some orders in there by default. Anyway, let's create some more orders. I think there's 2 in there by default, so we should have 5 orders. And so let's start by submitting some payments, just normal ones. Okay, I guess there was only 3. So, okay, so we've submitted some payments. So because we've opted into the registry, then it does record each of the 3 payments. That's what's getting, the payment is what is an event-based interaction. And so we see that the event type is this order paid object. The listener is the engine. And here's the serialized event, right? So, but those have been completed right away. And we can go to Zipkin. Let's start with Zipkin, 9411. Localhost. And we can run this query and sort by start time. Okay, and so this is kind of the results that you saw in the slide, right? So we made a call to the payment API. The payment API responded very quickly, but the payment API, what it does is it publishes an event through the application event listeners, which is captured by Engine. And Engine has a built-in intentional delay of a default of 2 seconds, just so we can see this. And this is also because we're also optionally using the event database. You saw that event being written to the database. Engine picked it up, processed it in 2 seconds, and so we saw it be completed. So that's pretty cool, right? That you can see order to payment, order, engine, et cetera, right? That's all there. Now, as far as the event publication database, how it can help us if something crashes, we'll just get ready to crash the application. Okay, so we're going to kill it. So let's go ahead and send a few more requests, order a few more drinks, and then we'll submit our payments. And we'll just try to time this right. Get the payments link, 1, 2, 3. Now we have 2 seconds to kill it. Okay, let's see. We got it. Okay. Ooh, did we? We got one of them. 2 of them. Okay. Okay, so we crashed the application. It had published the 3 events for the payments, but it had not finished processing them, right? Within those 2 seconds that it takes to process the payments, the application died. So we can just make sure that no matter what happens, right, the application is not running, those are not getting processed. So we can go back, and I can show you also in our application properties file that we have, here we are, opting in. This is how we opt into republish outstanding events on restart equals true, right? So it's optional. So we're going to start the application again, and we go back to our database here, and we refresh this. Give it a second to start. And it should, and it's republished our events automatically. So that's pretty cool. What else do I want to show you? And then, yeah, if you wanted to see, I guess what else is interesting here? So we're using the J molecules annotations here, like aggregate root, identifier, domain event. So we're using annotations to define this that are more in line, more semantically related to domain-driven design rather than more technical. So you don't see maybe some of the normal entity, et cetera, annotations that you might expect to see here. And then, but we are using, so it uses the domain event to eventually, where is it? Let's see. Right, so this implements domain event, so that eventually causes this, when it's saved, to publish the event. And then in the engine, this is where we're using the annotation that we were talking about before. So here's where we declare the listener. So by simply adding this single annotation, we have automatically incorporated that configuration where it is asynchronous and it starts its own transaction boundary. So super easy to capture that order paid event. So, okay, I think that's all to show you on this one. So let's switch over to, let's see. Let's do this one. So that's using the internal one. So here, just gonna, okay. Here we're adding under payments, a payment received event. And this one, we're declaring it as externalized. So on the actual event type, you decide that this event is going to be externalized. And with that, we'll be publishing to Kafka. So we should have also, we have Kafka running as well, and we can check Kafka here, refreshing every 5 minutes. We have, okay, so right now, I didn't restart it just to make things faster, but let's say I've already tried this 12 times just to make sure the demo would work. So we're going to expect this to go up, right? So now we restart our application. In the same profile, we just added a dependency for Kafka. Here you can see now this, we added Spring Modulith events Kafka. That's all you need to add. And we then made that externalized. So now, if we publish more information, let's add another one event, and then we'll submit the payment for that. And you can see that we should have now 13 messages. So that one went to Kafka. It also went to the database. So we go back to our event publication database. So this was before we refresh, right? We have 8 rows. And now in this version of the code, we should have, it should have, what's happening? We need to reconnect. I don't know why this didn't capture it. This should, let's try that again. There we go, okay. So that now we had 8, now we have 10, because we have the one for the order paid type, right, that we had before. And now we've added our, okay, now it refreshed, so it did both of them. So, and now it added for the payment received type. So it also uses the database for the externalized events. Okay, and then I think the last thing I wanted to show you is this one. Okay. So let's say that we have, okay, so in this one we're pretending we're going back in time, and we have some legacy code. So this is maybe before, so we've refactored much of our application, but you can see we don't have the drinks package anymore. Instead, we have a legacy package, and, oh no. Is this, maybe this is, okay. So we have our drinks, so we have some drink stuff, but we also have some HR stuff. We're not really ready to like sort of fully refactor this. I think this is intentional. So we go into our package info, into our legacy here. So part of the problem, yeah, I think this is how I set it up. We can't pass our tests because things are, they don't have we have access violations into the legacy package because we're trying to access things that are at sub levels. Right, so it's loaded. It's loaded. Okay, so you can see here that it's trying to run the tests. It's loaded the packages, so it sees that the legacy package is a package, but it's failing to load somewhere here. Maybe it should be more clear, but let me run the test from here. Let's run the modularity tests. Not that one. Maybe this will be more clear. Okay, so it can't verify our architecture for sure, right? So it says here, there's something in the legacy model drink within legacy that I'm not allowed to access, that I'm trying to access. So this doesn't comply with our architecture rules. So what I can do is come in and say, well, this is my legacy package. I haven't refactored it yet. So let's just make the whole thing open, and then we can rerun this test. And now we're good to go, right? So again, the benefit of this is that you still recognize it as a module. It's still going to see that, but it knows that it's all open, so it's not going to violate any access tests. And the other thing we have here is, I think it was this one. Let me try running this one. Was it this one? I had an example of, running, oh no, it's this one, okay. Okay, so here, we want to isolate the orders integration. So we've added this annotation that says application module test, and it cannot run just this because this has a dependency that it's not loading, because the default bootstrapping mode for just loading the orders module is standalone, and I haven't accounted for, I haven't mocked things out properly or whatever. I want to test it, but I actually do need to have my dependencies, so I can instead opt to bootstrap it either with direct or with all dependencies. I think in this case, this should be enough. And then I should be able to rerun my test. And you'll see that that should, well, it should work. Should have worked. I mean, I might have, let's see. Something else is wrong that I've done here. Let's try all, but I don't think that that's it. Let's see. I don't know if I messed something else up. Let's see. Context, get application context. Yeah, I might have messed, yeah, maybe I was playing with it and messed something else up. But I'll fix it in the, I'll make sure it's working in the repo if you want to check it out. But that should work. And I don't know what I did. But that configuration should work. If you just need the dependency, then that'll load the dependency. And it should be that simple to like just test one module. So almost a perfect demo. And I think that's kind of the content that I had. Yeah, the demos are here. I'll make sure the legacy one works. 10:50, I think that's kind of all the time that I have. I hope that was useful. I hope this project really helps you. I think it's a phenomenal project. I think when I learned about it, I know I remember in my career in like 2010 or whatever it was, working with a company that had SOA applications, and I was, looking at the developer team really trying to organize their code into services, but they still had to deploy everything as one, and everything was still kind of messy. I have this, sometimes I use these slides to kind of like talk about this and say like, what are really the relationships between your modules? Are they respectful of each other and each other's boundaries, or is it complicated? And I know that when I saw these SOA architectures, things were actually really complicated. There was an attempt to make it look organized, but in reality, these things were like all bundled together. And it was really impactful to me to see that on the development side, developers were really trying to modularize code, but because of the chasm between development and how operations could actually handle deployments, things were still being packaged together and things were still messy and hard to test. And so I felt like watching this whole microservices journey that we've been on over the last 10 years, and I'm sure a lot of people in the room have felt the same thing, that there's been this sort of like something's off, right? Something's missing. There's a hole that we haven't been filling. And I feel like when I saw this project, I remember telling Ollie that I feel like this is the project I've been waiting for 10 years, that it answers this question, it fills this hole. And so I think it's super exciting. So I hope it's really useful to all of you. And that's it.